Welcome. We're going to do a task 5.3. We're going to prove that segment CD is an angle bisector. So what that means, looking at this here, is that CD, segment CD, would bisect angle C into two congruent angles. And to do that, we're going to use the idea that this triangle is congruent to this triangle. And for that, we're going to look at, see if we can get side, angle, side. That would show the triangles are congruent. That would show that, therefore, if the triangles are congruent, we could say those angles are corresponding parts of congruent triangles, which are always congruent. So let's try it. The first two are given. ABC is equilateral, CE is a line of reflection. We'll use those same two for everything. So the next thing we need to do is we're going to say, well, because CE is a line of reflection, pick a different color here, then we can say that CD is perpendicular to AB, and we know that perpendicular means that CDA and CDB are right angles. So now, looking at our diagram, we are able to show, okay, take these off because we haven't done these yet, we are able to show that these two angles are right angles, and therefore, because they're right angles, they're congruent. The next part on this that we can use is the fact that D is the midpoint of AB. So, let's look at the reason. CD is perpendicular to AB, so we can say, and then we can say angle ACD is congruent to BCD, ACD and BCD. So angle ACD is congruent to angle BCD, and that was because right angles are congruent. And we also used the idea that CD was perpendicular to AB, and that was because of the line of reflection. Okay, and we know they're right angles because of the definition of perpendicular. So now we've got the angles. The other thing that's useful here is we can say, because D is the midpoint of AB, because it's a line of reflection, we can say that AD is congruent to DB. So we'll say AD is congruent to, I would say, BD. And that's because the definition of a midpoint. Okay, so now we've got these segments, side, angle, and then we can also say CD is congruent to itself, and that is right here, and that's the reflexive property. So we'll say that CD is congruent to itself, and that's the reflexive property. And all of that is trying to attempt to show that we have a triangle that's congruent to a triangle. So the triangle is ADC is congruent to BDC, side angle side. ADC, BDC, ADC is congruent to BDC and side angle side, and therefore finally we have the angle, and this angle was ACD is congruent to BCD. Okay, and that's because corresponding parts for congruent triangles are congruent, C, P, C, T, C. And so therefore, based on the definition of an angle bisector, CD is angle bisector, and that's based on definition of angle bisector. So when you're proving these, you're really justifying everything, and even down to the last step here with the definition.